Question number 25. Describe in detail the function of NAND gates and describe in detail how NAND gates can be used to substitute for inverter and OR gates. This is what a NAND gate looks like. It looks like an AND gate with a circle on the end. And logically speaking, it's an AND gate with an inverter attached to its output. So first you have an AND gate like XY, and then that output XY gets inverted. So the truth table of the NAND gate looks like a truth table for AND gate after its output's been put through the inverter. So instead of having zeros everywhere where I supposed to have zeros for AND gates, I have ones, and where I have ones for AND gate, I have zeros. So this is the truth table. NAND gate is a universal gate, which means it can be used as an inverter or AND gates. So this is how you turn your NAND gate into an inverter. You tie its inputs together and you feed it exactly the same input. So when you do that and you put it through the NAND, you get X and X not. But we know that X and X is always X. So this is just X not, so, or inverted X. So it comes out to be an inverter. And then you can use NAND gate as an AND gate. Now, NAND by itself is like an AND gate with a built-in inverter on its output, but we cannot take that inverter out. So to invert it back to what it originally was, the AND, we can add another inverter. So if you have a NAND gate and you put an inverter right after it, you will get the signal of the AND gate. And this is the Boolean algebra proof of this. So I have X, Y naught after the AND gate, and then I invert this again. The lines of the same length cancel out, and I have X, Y. And of course, you can use NAND gate as an OR gate. If we use De Morgan's on a NAND gate, it would actually give me, I break the line, change the sign, not X or not Y, which is almost an OR gate except my outputs are inverted. So if I invert them before I ever put them into a NAND gate, I should get an OR gate into the end, in the end. So over here I'm inverting X and inverting Y, so I'm putting in not X and not Y. And once they go into a NAND gate, when I break the line, change the sign, I end up with length with double lines of the same length, and they cancel out, and my final answer is X plus Y or X or Y. So that's how this combination gives me an AND gate as an OR gate.